Welcome, everyone. I'm excited to kick off this presentation on the fascinating journey of artificial intelligence. Today, we'll explore how AI has evolved from simple rule-based programs in the 1950s to the advanced systems that can now write, reason, and create. We'll start with a brief history, move through the development of search engines, and end with the rise of large language models. So, let's dive into this captivating story of innovation and progress. Now, let's take a look at the transformer architecture and how it has revolutionized language AI. Since 2017, we've seen models grow from just a few million parameters to trillions, enabling the development of large language models, or LLMs, that can understand and generate human-like text. This shift marks what we call the transformer era, a period ongoing since 2017. Before this, in the 2010s, neural networks with many layers, what we call deep learning, became the dominant approach. These models trained on massive amounts of data and achieved impressive results in image recognition, speech-to-text, and translation tasks, often reaching human-level performance. Going further back, in the 1990s and 2000s, AI systems relied on statistical methods. They learned patterns from data rather than following hard-coded rules, which led to the rise of machine learning. During this time, search engines, spam filters, and recommendation systems became much more effective. Prior to that, in the 1950s through the 1980s, we had rule-based AI, where programmers explicitly coded every rule. You can think of early chess engines and expert systems. However, these systems were quite brittle. They worked well within narrow domains but struggled outside of them. Putting it all together, this slide highlights the evolution of AI from rule-based systems to the powerful, data-driven models we see today. Each stage built upon the previous, leading us to the current transformer era, which is transforming how machines understand and generate language. This progress is at the core of the advancements we're discussing in language AI today. Let's take a look at some of the key milestones that have shaped the development of artificial intelligence over the years. In 2017, we saw a major breakthrough with the publication of the paper, "Attention is All You Need," which introduced the transformer architecture. This innovation has been fundamental in advancing natural language processing, including models like ChatGPT. Fast forward to 2022, ChatGPT launched and quickly gained popularity, reaching 1 million users in just 5 days, highlighting how AI is becoming more integrated into our daily lives. Going further back, in 2012, we witnessed a significant breakthrough when AlexNet won the ImageNet competition, dramatically improving image recognition capabilities through deep learning. Before that, in 2011, IBM Watson made headlines by winning against human champions on Jeopardy, showcasing how AI could handle complex language and knowledge tasks. Even earlier, in 1997, Deep Blue defeated world chess champion Garry Kasparov, demonstrating the potential of AI in strategic reasoning. Looking even further back, in 1966, the first chatbot named ELIZA was created, simulating a therapist and marking the beginning of conversational AI. And if we go back to the very origins of AI, it all started in the summer of 1956 during a workshop at Dartmouth College. Pioneers like John McCarthy and Marvin Minsky proposed that every aspect of learning and intelligence could, in principle, be precisely described and simulated by machines. This bold idea laid the foundation of the entire field of artificial intelligence, which continues to evolve today. Let's take a quick look at how these models have evolved over time. Starting with GPT-1 in 2018, then progressing through GPT-2 in 2019, GPT-3 in 2020, ChatGPT in 2022, GPT-4 in 2023, GPT-4o in 2024, and finally O3 or GPT-4.5 in 2025. Each new generation has been more capable than the last, and all of these are built on the same fundamental transformer architecture. So, what did this advancement enable us to do? Well, previous models processed text one word at a time, which limited their ability to understand context quickly. Transformers changed that by processing the entire context at once. This approach allowed for massive parallelization, meaning models could be trained on way more data, much faster. And why does that matter? Because it introduced a new way for AI to pay attention. Instead of just looking at words sequentially, the model can now weigh how relevant each word is to every other word in a passage simultaneously. This was a game changer for understanding language in a more nuanced and accurate way. This shift was all thanks to a groundbreaking paper titled "Attention is All You Need," published by Google in 2017. It introduced the transformer architecture, the foundation for every major large language model we see today. So, in essence, this paper really changed everything in the field of AI language processing. So, what made ChatGPT truly stand out was how conversational it was. You could talk to it just like you would with a person, using plain, natural language. It wasn't just a rigid program. It understood the flow of a conversation, remembered the context as you went along, and could even be corrected if it made a mistake. That's a big shift from traditional AI, which often felt very impersonal and limited. Another key point is that ChatGPT could perform dozens of tasks. Whether you needed it to write an article, summarize complex information, translate languages, generate code, explain tricky concepts, or brainstorm ideas, it could do all of that. And what's really important is that it was accessible to everyone. It was free and didn't require any technical knowledge to use, which meant almost anyone could start leveraging AI in their daily lives. This combination of accessibility, conversational ability, and versatility made AI feel much more tangible and personal for hundreds of millions of people almost overnight. It transformed how we interacted with technology on a daily basis. And what really set ChatGPT apart from all previous AI efforts? It was a consumer app that gained rapid adoption in history. In just 2 months, it became the fastest app to reach 100 million users. That's in just 5 days. This was truly the ChatGPT moment, marking a new era of AI becoming a mainstream, everyday tool. Now, beyond just text, the generative AI landscape has expanded dramatically. We're seeing models that create images, like DALL-E3, Midjourney, and Flux, which enable stunning visual content. In audio and music, tools like Suno and 11 Labs are revolutionizing how we generate sound and compose music. When it comes to video, platforms such as Sora, Veo, and Runway are pushing the boundaries of what's possible in visual storytelling. And it doesn't stop there. There are models for coding, like GitHub Copilot, Cursor, and Claude Code, which assist developers and automate programming tasks. Plus, we now have AI agents. These are systems that can take actions in the real world on our behalf, making decisions, planning, and even using tools to accomplish complex tasks. What's truly exciting is that these models are now capable of reasoning, planning, and using tools, moving beyond simple chatbots. This shift means we're essentially seeing the emergence of an operating system for knowledge work, transforming how we create, work, and innovate. Leading this landscape are products from major players. For example, Microsoft's Copilot, powered by GPT-4o or o3 on Azure, is integrated into many workflows. Google's Gemini 2.5 is another powerful model available through Gemini Google.com. Anthropic's Claude 4, used in Claude AI, is known for its safety and reliability. And OpenAI continues to advance with ChatGPT, now based on GPT-4.5 or o3. Overall, the AI landscape today is incredibly rich and diverse. It's not just about generating text anymore. It's about creating a comprehensive ecosystem that spans images, audio, video, code, and intelligent agents. This evolution is fundamentally changing how we approach knowledge work and problem solving. Now let's clarify a common misconception. Large language models, or LLMs, are not some kind of magic trick. They're not dangerous robots waiting to take over. Instead, think of them as highly sophisticated pattern completion engines. These systems are built by humans, trained on vast amounts of human-generated text, and shaped through human feedback. Because of that, they reflect both our strengths and our limitations. The more we understand how they work, the better we can use them, more effectively and, importantly, more safely. Grasping their nature helps us leverage their power without overestimating their capabilities or underestimating their flaws. This understanding is key to integrating AI into our work responsibly and confidently.